So what is the data augmentation? One of the issues that comes across while dealing with the image data is the inconsistency in the images, like some are either too big or small. And other frequently faced problem is the number of images in the training set, which often results in overfitting. So to deal with this issue, data augmentation is used. The images in the training set are transformed so as to increase the ability of the model to recognize different versions of an image. This increases the breadth of the information the model has. It now becomes better suited to recognize target objects in images of varied contrast, size, from changed angles, and so on. So, data augmentation methods are widely used in practically every cutting edge deep learning applications such as object detection, image classification, image recognition, natural language understanding, semantic segmentation, and much more. Data augmentation is used to transform the data or images to increase the ability of the model to recognize different versions of an image. This increases the breadth of the information the model has. Augmented data is improving the performance and the results of the deep learning models by generating new and diverse instances for training dataset. So for data transformation and data augmentation, you will be using the Albumentations library in Python. Albumentations is a Python library for image augmentation. Albumentations provide a single interface to work with different computer vision tasks such as semantic segmentation, classification, instance segmentation, object detection, and pose estimation, etc. Deep neural networks require a lot of training data to obtain good results and prevent overfitting. However, it often very difficult to get enough training samples. Multiple reasons could make it very hard or even impossible to gather enough data. For example, to make a training dataset, you need to obtain images and then label them. You need to assign correct class labels if you have an image classification task. For an object detection task, you need to draw bounding boxes around objects. For a semantic segmentation task, you need to assign a correct classes to each input image pixel. This process requires manual labor and sometimes it could be very costly to label the training data. For example, to correctly label medical images, you need expensive domain experts. Sometimes even collecting training images could be hard. There are many legal restrictions for working with healthcare data and obtaining it requires a lot of effort. Sometimes getting the training images is more feasible but it will cost a lot of money. For example, to get satellite images you need to pay a satellite operator to take those photos. To get images for road scene recognition, you need an operator that will drive a car and collect the required data. So here comes the image augmentation to rescue these problems. Image augmentation is a process of creating new training example from the existing ones. To make a new samples, you slightly change the original image. For instance, you could make a new image a little brighter, you could cut a piece from the original image, you could make a new image by mirroring the original one. So as a result, the image augmentation improves the quality and performance of the deep neural networks. To perform the transformations and the augmentation, so you need to import the Albumentations library in Python. So here you can see the different data transformations using Albumentations library. For example, here is the original image. You can see the original image and then RGB shift is applied to the original image and you can notice the changes and then you can see the transformation with the hue saturation value, then channel shuffle and then clay and then random contrast, random gamma, random brightness, blur, media blur, to gray. So there are different transformations available in the library that you can use and transform the image. Here you can see another example of the transformation. For example, here is the original image and then horizontal flipped image and then vertical flipped and then finally shift scale rotate of the original image. So there are different transformations that can be applied using this library. So there are two kind of transformations available in the Albumation library. So the first one is pixel level transformations. Pixel level transforms will change just an input image and will leave any additional targets such as masks, bounding boxes and key points unchanged. The list of the pixel level transformations is given below. You can see the advanced blur, blur, clay, channel dropout, channel shuffle and there is gloss blur, Gaussian noise, motion blur, media blur, random shadow, random snow, random sun flare, sharpen, RGB shift, equalize, emboss. So there are many transformations available in the pixel level transformations. And the second is spatial level transformations in the Albumamentation library. Spatial level transforms will simultaneously change both an input image as well as additional targets such as masks, bounding boxes, and key points. So the list of the transformation is given below. For example, a fin transformation, center crop, coarse dropout, crop and pad, lambda, grid dropout, pad if needed, pixel dropout, random crop, random rotate 90 degree, random scale, resize, rotate, safe rotate, transpose, grid distortion. So these are the spatial level transformation that you can apply the image as well as the targets such as masks, bounding boxes, and key points. Now let's define a Python function to transform and to augment the training images. So here is our get training augmentation function. So here you can see we have applied the resize the image into 256 into 416 with the probability, and then apply the horizontal flip, and then apply one of these transformation, that is random brightness contrast or clay or hue or saturation value, and finally apply the additive Gaussian noise. So this transformation will be applied to the training images, but you can modify or you can add more transformation according to your requirements. So here is the Python code to transform and augment the validation images or test images. So you can see the get validation augmentation function. So here we have applied only the one transformation, that is pad if needed, because we want to fix the image size 256 into 416 to make image shape divisible by 32. That could be the requirement of the network, but you can change according to your requirements. So validation augmentation we will apply to the validation data and the testing data to make sure the image shape is divisible by 32. And finally we have the pre-processing function. So why we need this pre-processing function? Because all encoders have pre-trained weights. So you need to prepare your data the same way as during weights pre-training may give you better results. So basically the pre-processing function is a data normalization function. It can be specific for each pre-trained neural network. So when you use the pre-trained encoder as it was used while pre-training that encoder. So here you can see the get pre-processing. It's take as a parameter pre-processing function, and that pre-processing function will be applied to the image, and then that image will be converted to the tensor. Here you can see the toTensor function. That toTensor function is defined over here. Now let's switch to the Google Colab so that we can run this code and we can see the output after applying the augmentation on the data. So here is our code. So first of all we will import the Albumentations. So let's run this code. So then you can see here our get training augmentation and get validation augmentation and then get pre-processing function that we have just seen. So let's run this code. Now here you can see we have defined another helper function to visualize the augmented data. So let's run this function. And then we have defined a data set that is basically the augmented data set, and we have passed the training original images and its corresponding segmentation mask. And here you can see in the augmentation part, and here you can see the augmentation parameter is equal to get training augmentation that we have just defined. And in the classes we have just passed the tray class so that we can see the augmented data. We will show the same image with different transforms. For example, we want to show the same image with 5 different transformations. So here you can see image mask is equal to augmented dataset, and select the 8th image in the training dataset, and then visualize the data where it will visualize the image and the mask. So let's run this code and we can see the augmented data. So let's run this code and we will see the same image with 5 different transformations. So let's hit run and here we go. So here you can see the output after the execution. So the same image with 5 different transformations. For example, here you can see the different transformation applied to the image. So that's how the transformation works. So we have applied the augmentation on single image. So you can see the same image with different transformations like rotation, scaling, and Gaussian noise. So I hope now it makes sense to you after seeing this output. See you in the next lecture.